Hello, everyone, and welcome to the ACM Learning webinar. And this webcast is part of the ACM's commitment to lifelong learning. This webinar is brought to you by the Special Interest Group for Artificial Intelligence, SIG-AI, and specifically the SIG-AI Industry Committee. We're planning to have monthly webinars on different topics of interest for those in industry and academics as well. I'm Hammond Petrov, Industry Liaison Officer for SIG-AI, and I'm also Director of Cognitive Technology at KPMG LLP, also Lab Director for the Dedicated Intelligent Automation Lab within KPMG Ignition, where we focus on areas such as artificial intelligence, natural language processing, knowledge representation, and reasoning machine learning. I also serve on the faculty of the University of Illinois at Chicago, where I teach graduate courses on artificial intelligence, natural language processing, and cognitive analytics. Also moderating the webinar today with me is Rose Parody. She's Secretary-Treasurer for SIG-AI. Rose is a Principal Research Engineer at Leidos Health and Life Sciences, where she works as a data scientist for big data analytics that includes building models in computational linguistics and natural language processing, machine learning, and artificial intelligence. You can find more info on our backgrounds in the bio widgets on your screen. Today's presentation is Communicating with the New Machine, Human Insight at Machine Scale by Kristian Hammond. And I'm pleased to have Kristian present. He's a professor of computer science at Northwestern University and also co-founder of an interesting company called Narrative Science. For those of you who may be unfamiliar with ACM and SIG-AI or what it has to offer, here is some information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources that you can find at learning.acm.org. You can see some of the highlights on your screen. The ACM Special Interest Group on Artificial Intelligence is made up of academic and industrial researchers, practitioners, software developers, end users, and students. And our goal is to promote and support the growth and application of AI principles and techniques throughout computing, sponsor or co-sponsor high-quality AI-related conferences, publish the quarterly newsletter AI Matters in its namesake blog, organize the Career Networking Conference for early-stage researchers in AI, sponsor recognized AI rewards, support important journals in the field, provide scholarship to student members to attend conferences, and promote AI education and publications through various forums in the ACM Digital Library. And AI is increasingly an interdisciplinary area, and your membership supports these goals. You can join us today by going to the link on your screen or Googling SIG-AI. Both members and non-members are welcome to join our mailing list to receive timely announcements of interest to researchers and practitioners. And before we start, a few housekeeping items. First, the slides will advance automatically throughout the event. On the bottom panel, you'll find a number of additional widgets and resources. If for some reason you're experiencing problems with the slides or audio, please press the F5 key on Windows or Command and the R key on your Mac, or refresh your browser on a mobile device. Worst comes to worst, you can close and relaunch the presentation. To control volume, adjust the master volume on your computer. If you have questions during the webinar, please type them into the Q&A box at any time during the webinar and click the Submit button. Rose and Plum organize the questions as Kristian speaks, and we'll reserve some time at the end of the presentation to address them. The session is being recorded and will be archived, and you will receive an automatic email notification when it becomes available. You can also check at learning.acm.org for updates on this and other upcoming webcasts. And at the end of the presentation, you'll see a survey open on your screens. Please take a minute to fill it out to help us improve our webinars. We may also open the survey at any time throughout the presentation from the menu dock at the bottom of your screen. All right, and today's presentation is Communicating with the New Machine, Human Insight at Machine Scale by Dr. Kristian Hammond. A very quick introduction. Chris is a professor of computer science at Northwestern University and the co-founder of the artificial intelligence company Narrative Science. He has spent most of his career focused on the problem of making machines smarter. Since the fall of 2016, he has been the faculty lead of the university CS+X initiative, where he has been exploring how computational thinking can be used to transform fields such as the law, medicine, and education. He's also the director of Northwestern's Master of Science in Artificial Intelligence. He's an ambassador at large for the IBM AI X Prize and was recently a member of a UN policy committee examining the issues of autonomous lethal devices, also known as killer robots. He believes in humanizing computers with the aim of stopping the process of mechanizing people. Chris received his PhD from Yale University. Kristian, without further ado, please take it away.
Okay. Thank you, Plowman, and thanks everybody. Thanks everybody for joining us today. I'm going to flip over to my screen and get us started. Yeah, today I'm going to talk about language. It's probably important to clarify what the two sides of me actually mean in this context. So I'm a professor of computer science focused on AI at Northwestern, and I'm also co-founder and chief scientist for this company, Narrative Science. From the first, that is my university connection, you really want to walk away with the idea that I care about the world of ideas, and I care deeply about the world of ideas. On the narrative science side, the thing you want to walk away from is the idea that there's a notion that I also care about product, that is, producing systems that actually work in the world, that satisfy human goals, and can be deployed at scale. And so those two components are going to show up in a lot in this talk today. But we're really going to talk today about this notion of the relationship between computers and language. And it's important to understand what I mean when I'm talking about language. And in order to get you that understanding, I'm going to tell a story. It's going to be a simple story. And the point of me telling you this story is not the point of the story. It's that it is a story. And it's a story about my father. And it's as simple a story as I can actually tell. And that is, he was an orphan and became an archaeologist. And from that, you got to realize that he had absolutely no knowledge of his personal past, but he spent his entire life, his entire career, uncovering the past of others. And you look at that, and you now have an idea of this man in your head. You know what drove him. You know what decisions he made. You know the things that really compelled him. And you know that because you understand what it means to be an orphan, what an archaeologist does. You understand people's goals, people's pain, people's aspirations. You know all those things, and as a result, you can fit these simple ideas into a complete image, a complete story, a complete idea. And I know that you know those things. And so when I present things to you, I can actually present them with a fair amount of confidence that you'll be able to put together the pieces, draw the appropriate inferences, and understand things at a relatively deep level. And the point here is that language is more than words. Language is really a collection of stories, of connections, of us being able to explain things. And it allows us to, I think, in an amazing way, to connect with each other, look at the past and explain the past to each other, communicate what's going on in the present, and actually project what's going on in the future, what's going to happen in the future. By its very nature, language is miraculous. It's a stunning feat that we can actually talk at all. And it is a hallmark of intelligence. That is, the ability to use language is emblematic of intelligence. And it's uniquely human. That is, as we look at dogs, we can train dogs to do tricks. We can train actually dogs to understand commands. Beavers can build dams. Crows can use tools. But there is no other animal that is able to look at the world, understand it, and then communicate it to others using language. But we actually have this new partner, and that's the machine. And the machine actually struggles with language. And it struggles in ways that are sometimes not apparent to us, because we are now surrounded by devices that actually seem to be picking up on the language that we use. But the reality is they're picking up on the words. That is, they can understand the speech, turn that speech into words, and then do something with those words. But it's very different than understanding language. If you talk to the people who actually are sort of in the midst of building out personal assistants and communication systems like these, actually often they will refer to their goals as being driven by situations like you see in Star Trek. And they'll talk about how they want to build a computer that's just like the computers on Star Trek, where you just tell them and you communicate with them in language. But I actually went back and took a look at old episodes of Star Trek and how people talk to computers on Star Trek. And in particular, I was always interested by the fact that Jean-Luc Picard in the Next Generation would go into his stateroom, and he'd be tired. He might have been in the middle of a battle. He might have lost some crewmen. He's got something stressful going on, and he would go into his stateroom and he would say these simple things: Tea, Earl Grey, hot. Tea, Earl Grey, hot. And I look at that and I think, well, that's not really language, is it? That's a SQL query. That's a database query. That's not language, and it really doesn't involve the machine knowing anything about him or what he really wants, because everything is contained in that utterance. And that is, there is no room for the machine to actually know that when he comes into the same room that he is going to want a cup of hot tea, of Earl Grey tea. And actually, it's kind of odd that he always has to say hot, because he never has iced Earl Grey tea. And you really want the machine to actually, as he walks into the room and says something like this, tea, Earl Grey, hot, you want the machine to say, why are you talking to me that way? You don't talk to regular folk that way. That's not language. Stop giving me commands in this weird elliptical, non-linguistic way. And so that's the issue. Now, the reality is language for us is a window on the world. It's a way for us to understand what is happening in places we have not been, through reading or through hearing others talk about what's going on. But right now, that window is absolutely locked to the machine. It doesn't understand language. It actually uses words, and those are very different things. The danger here and the challenge, and now the opportunity, is that the machine knows a tremendous amount, and it can say very little about what it knows. Now, if you think about the machine's world in the old days, for those of us who have been in computer science for a while, the machine's world used to be a world of knowing about the things that were important to it, passwords and utilization logs and the applications it had. But things changed fairly radically. Once we had the network, not just the web, but the network, the machine started capturing information about our searches, our transactions, the pages that we view. More generally, it began to grab hold of information about jobs, about immigration, about the effectiveness of drugs, the stock market, educational impact, certainly all the census, health and traffic information. This all doesn't go to one place, but it's all being captured. And what's amazing is at this point, we are looking at a world in which we are capturing 2.5 zettabytes of data every day. Every day. And for most people, that's actually not a real number. I mean, who knows what a zettabyte is? And to give it just a tad more context, This is the equivalent of 250,000 libraries of Congress collected every day. Now, it's true that 80% of that volume is pictures of cats, but we have that data, we're collecting it, we're gathering it. And the reality is that machine captures everything, absolutely everything about the world that can be metered or monitored. And what are we doing right now? What are we up to? Well, we're trying to meter everything. And if you think about it, what we want to be doing is we want to be capturing as much data about the world as we possibly can. Because what we want to do is we want to use that data to make informed decisions, to understand the world with greater and greater depth. It's part of our endeavor, both in terms of science and in terms of business, of commerce, of even understanding our own lives. The more data we have, the more we might be able to do with it. But as we collect this data, especially in the world of the Internet of Things, as we collect this data, we find ourselves in an interesting place. And that is we have this massive data, this absolutely stunning massive data, which if you go to Google and type in data, this is one of my favorite things. If you go to Google and type in data, you get images like this, which are very pretty. But that's not what our data looks like. On a good day, this is what our data looks like. And it's not little spreadsheets that we can look at and suss things out. We're talking about tables that are thousands of columns, millions, tens of millions, hundreds of millions of rows that are changing all the time. So the data we have today, the data we're collecting today, is actually no longer human. It's no longer something that we can look at directly, that we can understand directly. So the question is, how are we going to find meaning in all this data? How are we going to interact with this data in a way that actually is powerful enough for us to understand what's going on in the world, but actually scales? And for me, the answer to that is natural language generation. And in particular, it's the notion of looking at the world of data, structured data in this instance, structured data, and figuring out how to take all those little data elements and have a system look at those elements, figure out what's going on in the world, and then tell us about them. And I will give you the simplest of examples. This is a very, very simple table, about as simple as a table can be. It has three columns. It has a quarter, a product ID, and sales numbers. And so what we're getting here is, over the course of a year, the quarterly numbers for two products in terms of sales. And of course, we want the data to be well normalized, and so we have another table that gives us the ID and maps it off to the name of these two products. One of them is the overly large widget, badly named by some random marketing department, and the small light widget. Now, almost anyone who is on this webinar will be able to look at these two tables in a matter of minutes, figure out what's going on, and report on it. That is, tell me about it, tell somebody about it. So they didn't have to look directly at the data. What's much more interesting for me is that I have a machine that can do that. I have a machine that can look at this data and actually say, while still slightly better than the sales of the small light widget, sales of the overly large widget have been on the decline over the past year. During the same period, sales of the small light widget have been steadily improving. Now, you notice there are no numbers in this, but what you're seeing is actually a communication about what's happening in the world. So this is not a reflection of the data. This is a reflection of reality, of what's happening in the world through the lens of the data. Now, this has been with us for a while. This notion of natural language generation has really been with us for quite some time. And in fact, I will often say that almost everyone I know, almost every colleague I have in artificial intelligence, at some point wrote a natural language generator, because you'd build a system, it would have an internal representation, and you'd want to understand what it was doing, and you didn't want to have to read all the representational elements all the time. And so you build an NLG system to look at the representation and spit out some language for you. And so you build a generator, and that generator would look at a set of facts and then turn that into language. And so this has really been, this core notion has been with us for quite some time. But I want you to think about this, this example and these two tables. And I want you to ask yourself, where are the facts? Now, from your perspective, you know what's going on here because I told you. That is, I explained the schema to you. I told you that the quarter, this column was going to be some designation of a time period. You know that the product is an entity that I'm going to be talking about. You know sales are actually a reflection of a metric. And in fact, you not only know that it's a metric, you know that for sales, up is good and down is bad. And in the second table, you know that this is the name of these products. That is, you know how to do about the mapping between the product ID from one table to another table to get across the name. Which is to say, the facts don't exist in this data. The facts exist in a combination of the data and the schema that's in your head. And that's in general how we deal with data, when human beings are dealing with data. And that means that when I get to sales of the overly large widget have been on the decline over the past year, in order to get there, I don't just need the data. I need to understand what the data means. So generating language, actually generating language from data, requires understanding the world. It requires having some sort of schema that you use as a driver for the information that you have. So for example, this is a data set that's associated with Salesforce. That is, it's the data around Salesforce and a team of people who are selling products. And the data actually captures some product information, some individual salesperson information, some information about different companies and what they buy. But what's important is that you can take a look at that data and you can turn it into this. That is something where the system starts off knowing that what it's doing is it's producing a sales report. And it knows when it's looking at a sales report that it's looking at performance, that is, how is an individual doing, and progress, that is, how are they doing compared to the way they did in the past. It understands the idea that some kind of performance could be exceptional, some kinds of performance could be someone doing extremely well. It understands that there's a team. It understands that, that you can be ranked with regard to that team, and you could be at the top or near the top. It understands the notion of time and change over time, and so that you can get to the idea of overall improvement across a set of metrics, not just one. And my favorite thing is that it understands that there's some relationship between different kinds of elements in this data. That is, when you're doing sales, you not only have data around the sales you've closed, but you have data around the sales you might close. And in this instance, because the system starts off with an understanding of what that relationship should look like, it can evaluate the comparison between the sales that have closed and what might close, what the pipeline, what a salesperson's pipeline looks like, and evaluate whether or not the data associated with that pipeline is any good. Because it turns out most salespeople don't put data about possible prospects into their data set. They wait until they get a little closer to closure in order to do that. But the system, by understanding the relationship of the data that it's supposed to see, can actually evaluate not only what's going on in the world, but the data itself. Now this is, as I said, I wear two hats. This core notion is what we work on at Narrative Science. And it's the idea that you start off with a collection of data, structured data, the numbers and unambiguous numbers and symbols that in some way, if you think about it, describe the world. But that description only makes sense when you understand as well the schema, which is not the data itself. It's something the system actually has to have in its model of the world. You analyze that data, and the combination of the data and the schema gives you a set of facts. And once you have a set of facts, you can look at those facts and start drawing inferences about them. What is more or less important? What should or should not be actually involved in an overall narrative? So if I'm looking at a data set and I care about how somebody ranks. And I look at, I sort a set of people with regard to their ranking for how many customers they've closed this month. I might be able to say that someone is at the top, but if I look at it from a statistical point of view, I might realize, oh, it's not one person at the top, it's a collection of people who are pretty much identical. And understanding that with regard to what's important, what's interesting, and what can be said is what you do in that inference phase. So facts alone are not enough. You have to figure out what facts are important, what they mean, whether or not they're valid, and use that to actually put together an outline of what you want to say. And once you have that outline, you can go to that wonderful final stage of looking at that outline and invoking a generator that will turn that outline into a narrative, an actual description, English language description of what's happening, again, in the world through the lens of that data and an understanding of what that data means. And this is what we do. This is what the Quill system does. It takes data and it generates language, descriptions of the world. Sometimes there are numbers in the language, sometimes there's not. The descriptions of the world through the lens of the data that is available to it. The power here is actually that what we're looking at is an integration of really three different notions. There's data and data analytics. There's facts and semantic inference. And there's language and natural language generation. Those three components are absolutely essential to building a system like this. And I want to actually just walk you through a few examples of what this means. Because the power of this is that we can actually turn the world of data, where people really struggle with that data every single day, and turn it into a world of information that they no longer have to struggle with. And this example I like in particular because this was something that in the early days of narrative science, we were wandering around. I was in New York with one of our salespeople, and we were running through a Whole Foods. And she pointed to somebody who had a clipboard with a spreadsheet on it. And she said, "Are we going to be able to fix that?" And I said, "Of course we will." Because that spreadsheet is data that somebody who runs a deli, a bakery, the produce section, the wine section, the cheese section, data that they don't want to have to deal with. They have to, because that's the way the world is now. But what they really want is they want to know how things are doing. And it turns out we ended up with an example and a client where they had exactly that. They had data on all of their stores, a whole set of grocery stores. And they were sending data to the people who ran the bakery and the deli, and the people were ignoring it because they didn't understand it. And in fact, they couldn't send them everything they wanted to send them because that data set was just way too large. And so we took that data, the sales data, inventory data, the store demographics, and we turned it into a story that would go to the person who was running the deli, the person who was running the bakery, the produce section, once a month. And it would tell them how they were doing. But even more powerfully, it would tell them what they might do. And that is, it would say things like, although the opportunity to reduce loss is the highest for self-service cookies, concentrating on European heritage bread may have greater impact overall, as it consistently has the higher sales. Which is to say that although you might want to stop people from stealing your cookies, you really want to actually think about pushing sales of this other product, because the margins are greater, the sales possibilities are greater, and that's a place where if you've got waste, you're going to lose money in a different way. Now the data associated with that isn't just how your unit has performed, but a whole bunch of other background data about the cost of things, where they're selling elsewhere. All of those come together to give you a piece of advice based upon the data. And advice that is not just valid, but actually linked to language, expressed in a way that you can understand. Now this there are sort of the world of grocery stores is fantastic, and it's nice to be able to do this for people. But there are also places where there's data that we have that no one can use at all. And one of the powers of the technology is really this notion of democratizing not data but information. So in Chicago, we have this absolutely wonderful system in place, and that system is aimed at taking sensors up and down the lakefront, taking sensors and gathering data around water quality. And what the sensors gather is temperature, water movement, certain chemical compositions, something called turbidity, which is to say particulate matter in the water, and it just collects that. And what you see here is actually an example, a real sample of the data that is collected. The samples are pulled out once an hour, all up and down the lakefront. Now the problem is that even though this is published data, there are maybe, on a good day, 5 people in the city of Chicago who could look at this data and know enough about water, what matters in water quality, how to inspect the data, how to actually analyze the data, so they can actually pull some insights out of it. So any given day, maybe 5 people can actually interact with the data directly. But you can take that data. In fact, we took that data, and we turned it into a narrative that would go out once a week. And what's fun about the narrative is that, one, it tells you about the best beach. For the week ending July 16th, 2016, 63rd Street Beach was the cleanest beach in Chicago as measured by the cloudiness of the water. That's great. It's terrific to know what the best beach is. But, perhaps more important is to know what the dirtiest beach is. So Ohio Street Beach was the dirtiest beach in Chicago. And even more important is to know if you were going to go to Ohio Street Beach and it's dirty, what beach should you go to? And that's beachgoers should be advised that there's an Oak Street Beach that had a better than average cleanliness rating. Oak Street, by the way, in Chicago is close to Ohio Street Beach. So if you were heading to Ohio Street, you can get to Oak Street Beach easily. You can take your family there. Now, what's important about this example is, one, it shows that you can really do this kind of analysis and pulling out of information from a lot of different data sets. But much more important is that you can take a data set that might be useful to 5 people and is useless to everyone else, and turn it into a piece of information, a narrative, a story that anyone who wants to take their kids to the beach can read. That anyone who wants to make a decision about cleanliness for their kids can read. That is, in Chicago, that millions of people can read. And so the difference between 5 people and millions of people is not the data. The data is always there. It's the ability for a system to look at the data, analyze the data, understand what's happening, understand what needs to be said, and turn it into language that anyone can read. Now, those 2 examples were really aimed at understanding past performance, understanding what's happening now. But there is no reason why this kind of technology couldn't be used to think about the future. And so we looked a little bit at the idea of standardized tests. Now, usually when people take standardized tests, they will be looking at, in terms of results. And it's like you should think about the last time you took a standardized test, or if your kids are taking standardized tests. As you look at results, what you're looking at is a world of score and a percentile. So you take your test, you've been studying for your test, you go in for 3 hours, you take the test, A few weeks later, you get back a piece of paper that says, and it's broken down into areas, but it's like you got an 85, and as a result, you're in the 87th percentile. Like, great. Now, you might actually also get, oh, and by the way, last year, you got an 83, and you were in the 84th percentile. So you're doing better. Great. Absolutely, when it comes down to it, meaningless information. But I want you to think for a moment about what kind of data is in those test data sets once they're done. The people who put those tests together, when they present you with 4 possible answers, one of those answers is right, and that's great. And the others are wrong, but the others are wrong in specific ways. And in fact, can be used to diagnose the ways in which you are confused. Once a whole bunch of people have taken the test, they know which answers were hard and which answers were easy. They know which answers actually correlate with, which correct answers correlate with people doing well in general. But you can't sit down with all that data and generate something for every single person who took that test, unless you're a machine, and a machine can do that. And certainly you can still get the retrospective. In physics, you need to focus on issues of magnetics and electrostatics. You seem to be having problems with some of the basic questions in these areas that other students are managing well. So you can look backwards, and you can get an idea about how you're doing and how you compare. Much more powerfully is you should look back to sections 3 to 5 in chapter 7 of the material for magnetics, and section 3 in chapter 6 for electrostatics. That is to say, by understanding the relationship between the answers that you got wrong, and in many ways, why you got them wrong, the ways in which you got them wrong, you can turn what have always been sort of these evaluation systems for students into something much more powerful. It can become part of the overall educational curriculum. It could be part of the educational process. That is, you take a test, and the system, which has access to everyone else who's taking this test, it has access to every single question. Why different answers that are wrong, and the ways in which them being wrong are diagnostic of what you may or may not know. All of that can be taken and turned into something that can be proactive with regard to helping you as a student know what to do next, what you need to learn, and the way in which you need to learn it. And it can do that at a scale and a level of precision that is simply not possible in terms of brick and mortar systems and human systems. We have neither the time, the focus, nor the skills for that to happen. But with a machine, it can. So the notion here is really all driven on top of a concept that is referred to as narrative analytics. And it's actually a kind of straightforward idea. And that is, when you generate language, you're generating language from meaning. That is, a system that's going to give you language has to have some idea of what it's going to tell you. And that idea has to be what it wants to express, not how to express it, but what it wants to express, the meaning that it's going to present you. But then when you back off from that meaning, you realize that, oh, the meaning in this instance flows from some analysis that you have done of data. And it really is, I think, for me, the interesting part of this is that if you think of the entire world of data analytics, is the reason why we do data analytics. The reason why we analyze data is because we know that analysis will provide us with meaning. We sort things because we want to know how they rank. We do time series analysis to see how things are improving. We compare things against benchmarks to see how well they're performing against goals that we have. All of these things are well understood in terms of analytics, and actually come out, end up producing meaning for us, which then can be turned into language. And of course, the analysis we do is driven by our goals. What do we want to know about the world when we're looking at these things? If I want to know how something ranks, then the analysis I'm going to do is to sort it. And that means I can just tell a system what I want to know is how something ranks, and it knows what to do in order to get the right meaning, to do the right analysis, get the right meaning, and then turn it into language. And the goals come from us. What do we want to know about the world? The thing that's astounding is that this scales. And this is just one example of what I mean by that. And that is, imagine that you have an entity and you care about how that entity is performing. And I don't care what that entity is. It could be a company, it could be an athlete, it could be a division, it could be a product, it could be a student, it could be anything. It could be your dog and training it in something. But given you have that entity, if you also have a metric that is the thing you care about in terms of that performance, that's terrific. Because then what you can do is you can think about how that metric has changed over time. It could be year over year, month over month. And if you want to really look at not only how it's changed over time, but how its change over time is actually functioning. That is it just not gotten better, but it's getting better at getting better? Were there inflection points? Were there problems? Was there a turning point? Then you'd want to look at historical trends or time series analysis. But for any metric, you might care about how it breaks down into pieces. So if I'm looking at how a student's performing, I actually probably care about, is it the homework? Is it in-class participation? Is it the testing? Is it their teamwork? What are the different drivers associated with these metrics? And once I have that, I've got to think about, oh, I'm looking at this thing with regard to a group. And so I have to have this notion of a cohort. So I can compare this one individual, this one entity, against other things in this cohort. And likewise, I might have a specific benchmark. It might be I want to compare my mutual fund against the S&P 500 and see how it's doing with regard to the stocks in general. And then for the metric, did I have a specific target for today? Do I have a goal for the future? All of these come together to make up what you think about when you're doing performance review. And not just what you think about for a student, but a student, an athlete, you're training your dog, a company, an investment fund, your portfolio, the utilization of electricity in your home, how well you're driving. All of these things can be expressed in this structure, this fairly abstract structure. But this is what drives decisions about the analytics. This is what drives the generation of meaning. And it's only the domain itself. That I'm talking about a student, and so I talk about grades. Then I'm talking about a company, so I talk about revenue. It's only that final moment where we actually bring it to language, and that's where the domain comes back into play. And the thing about this is that the examples I've shown you have been about data, but it's really important to understand this is not just about data. It's incredibly powerful. It can scope across essentially any structured data set. If the data set has meaning to begin with, then you can turn that meaning into a description of what's going on in the world on the basis of the data. But there's more to it than that, and particularly in the current world of AI. And that is, in the current world of AI, we have a lot of systems that are out there. There are in a growing number of systems, and we're moving them into the enterprise. And part of what we're looking at here is not just about explaining data, but actually explaining machines, explaining AI through the data that they produce in their reasoning. Which is to say, when you look at a system like Watson, that does unbelievably powerful and exquisite reasoning based upon looking at thousands of examples and matching with hundreds, hundreds or thousands of patterns to come up with its answer. You want something more than a number. You want to have an explanation of how it found its answer, and not just a picture of how it found its answer, but an explanation. If we look at deep learning systems today, where we have hidden layers which are doing a lot of processing, we need to be able to open them up and turn them into the data requirement that will allow us to generate explanations. Because if I've built a deep learning system that takes a look at demographic information, or payment information, or employment information, and says yay or nay to giving someone a loan, that system needs to be able to explain how it did that. And so this isn't just about data that is produced by sort of random systems that are growing in the world. This is about integrating with other AI systems and doing what we used to do, but doing it in a better way. And that is, you build a system, it's got some internal representation, you want to generate language out of it. But now you've got a system, and it's had its own reasoning. And you want to use the data associated with its reasoning to generate new articulations of what it was doing. With language, we are going to be in a place where the machine can actually share its stories with us. With language, we can free the information that's trapped inside this data. And with language, we can humanize the machine so we can stop mechanizing us. And in the world of data, there's a thing I do for live audiences, and I ask a question, and that is, how many people in the last week looked at a spreadsheet? And my guess is we were asking you to do commodity data analytics with data, as opposed to bringing the machine to bear so it can actually tell us in a human way what's going on in the world, instead of asking us to be like it and have it be that everyone has to be a data scientist in order to make use of the wealth of information that is available to us. And we want to stop that, and language gives us a mechanism for that. Because we want to empower the machine to become our partner. Because let's face it, AI and computation in general is everywhere. And the world is now more than computer science, and AI is more than computer science. And when you think about it, what the future of AI is really going from pure artificial intelligence or pure machine learning to add in the world of data analytics, human-computer interaction, human cognition, computational social science, so we can understand networks of people and how they respond to information, to all build out towards a model of integrated intelligence. And it was mentioned up front that one of the things I am is director of the master's program in artificial intelligence at Northwestern, which is a program that is aimed exactly at this, and that is thinking not just of AI all by itself, but thinking about, as Tom mentioned earlier, thinking about it integrated, thinking about what does it mean for AI systems and human systems to work together, and our push towards artificial intelligence, our push towards training a generation of students who are not just developers, but designers and architects for the future, is to give them an idea of not just how the technology works, but how it embeds, what it means, what its impact is, and what does it mean for humans to interact with it. And that's part of what we see as the future of artificial intelligence. And with that, I will open to questions.
Thank you very much, Chris. Rose, if you want to kick off with a question.
Yep, I have a few questions now that I'm combining. So one of them is, how do you update the schema when it changes? And in particular, can you walk through a use case of the change in software data analytics code associated with the recent adjustment of gender to a non-binary dimension?
That's a good question. I'll tell you in general, the notion is that from the analytics perspective, the analytics themselves don't change all that much or often, because no matter what, if you're looking at, no matter what the objects are or the metrics are, if you're looking at answering the question of is something getting better, you still want to do either a time series analysis or a time against time analysis. You have to understand the metric, and the data may change, the structure of the data may change, but that ends up being a change at sort of the ETL side, that is bringing the data in. And so we have tremendous stability around the particular pieces of analysis that we do. because the particular pieces of analysis are aimed at the kinds of questions people ask of the world. And it's like, what was the most important driver for a metric? How does somebody rank? How does the thing rank? Is something getting better? How well is it doing compared to some long-term target? How well is it doing against the benchmark? These are all questions where the analysis to answer those questions is always going to be the same, because it's the same kind of questions, the same kind of analysis of the world. When the data changes, and that is that, so when the data change, and you might have a new schema, the schema itself is not mapped directly onto the system. What it is the system's notion of what the schema means is not on the system. And you can change, if you have things like changes of field names, even changes of how the data is organized. It may be aggregated in different ways. That ends up being a change, again, at the ETL side. In terms of gender, it's the same, it's the same thing. The system itself, in terms of, two things. One, understanding that that you're looking at not male-female, but other possibilities. Just opens up the world in terms of what it's going to be. If it's in the data itself, what's discoverable. And then on the language side, it's simply literally adding new pronouns or ways in which to express those pronouns. And the thing that's the most exciting is that the core of the system remains astoundingly stable with regard to different problems and different use cases. And the edges of the system, which are exactly how to articulate things, or exactly how to ingest the data, those may change, but they change in ways that are not. I would say anyone from an AI perspective, they don't change in ways that sort of change the core ontology for the most part. But that was a good question. It was a good question.
Okay, another couple of questions is how do you validate the narrative, and how does bias affect the narrative?
Again, excellent. That's a really great question. In terms of validating the narrative, it's interesting. When we started looking at these problems, for a lot of people, they thought, oh, what we're going to do is we're just going to read everything it generates. But the system, there are some places where we generate millions of stories on an annual basis. So one of the groups we work with is a company called Game Changer that has a scoring app for kids playing Little League, and we generate game stories off of that. And we generated about 4 million of them last year. So no one's going to read all the stories. But the question, the thing it turns into is, oh, well, where would there be things that we need to validate? It's like, all right, so we need to validate the analytics. That is the analysis that's done in order to generate a set of facts. And then we need to validate any inferences that are drawn from those facts. And then the system has a notion of things like thresholds that will be impactful with regard to word choice, and we have to validate those. And there, it's very interesting. And that is, we have a system that can generate millions of stories, but the components themselves that need to be validated end up being a relatively small number. And once you've validated that your time series analysis works, you kind of have done it. And since it doesn't change a lot, you usually don't have to go back to it. You have to change things at the level of things like thresholds. So it might be a moment where you decide you want to call something extraordinary. And you want to call it extraordinary if it hits a certain threshold. And it could very well be that one person believes extraordinary, you say extraordinary if something is in the top 10%. But someone else says, no, it's going to be in the top 5%. So things are changeable for those people, and they get to actually give their own voice to the system. And so we do that. Now, within the confines of that, though, one of the things that we do is actually maintain a trace of everything the system has done with regard to its reasoning for generation. And that is that we hold on to every decision that went into every single word. And so you can look back and see where all the what components were used. And if there's if there's a problem if there's a problem that comes up, you can go through and figure out where that problem occurred. It does not happen to us often. As to bias, there are a couple places where bias can show up. One is the data itself. If the data that the system is being handed is by itself biased, or the metrics that someone thinks are important, those can be biased. When I was talking about the word selection, there are places where there are thresholds, and if someone wants one threshold or another, that might put in a bias. But again, the difference between a machine-generated piece of text, a machine-generated story, a machine-generated narrative, is that if there's bias, you can uncover it, you can unpack it, because you can see every decision it made. And so bias is not a hidden thing for Quill. It's a thing where if it shows up, we can immediately identify where it came from. And that ends up being an incredibly powerful tool because the system itself is designed to be truth preserving. That is, when it's starting with data that's true, it will generate stories that are true. And there may be nuance in the language, but it's aimed at preserving that truth. And for us, it's important to not only preserve the truth, but preserve the thinking that the machine did, so that if it made a mistake, we can actually intervene.
Okay, we maybe have one. We have a lot of questions coming in, and I'm sorry we won't be able to get to them all, but we do have another one. Maybe time for one more. Language is only one part of the human experience. Do you see a trend for AI to participate in more parts of the human experience? Can you let us talk about other ways of expressing means for AI than language?
Absolutely. That's a good question. It tends to be. There are places where it's not where I work, but I think the first thing that sort of people normally see when they see what we do in terms of generating language is they ask the question of, well, what about visualization? And for us, it's like, of course. And then it's like, okay, then what's our take on visualization? And our take on visualization is you show people viz to express meaning, and there are some times where the meaning is expressed better, faster, stronger with a piece of visualization. And in fact, we incorporate viz into a lot of our stories, and the system makes decisions about the visualizations it'll include. We're also on the other side, that is, we're integrated into visualization tools such as like Tableau and ClickSense. So we're part of that. In terms of other components, the thing that we do is really, in some sense, think of it as it's nonfiction. I mean, we describe the world by using language. And that tends to be one of the primary ways in which people describe the world to each other. But there is no reason why a system that looks like Quill could not also generate music that describes the world. There's no reason why it couldn't generate animations. There's no reason why it couldn't generate sort of other kinds of experiences. For us, though, it's because for us the limiting factor is we want to free people from having to deal with all of the data that they're constantly confronting, and move into a world in which they can simply understand in a very human way what's happening, even though underneath it all is a lot of numbers, a lot of analysis, a lot of computation that's sitting on top of maybe hundreds of millions of bits of data. All of that can be turned into something that they can understand. And that's what we're striving for.
Thank you, Kristian. I'm afraid we've run out of time for today. So I'd like to thank Kristian Hammond again for his informative presentation and the great answers to the questions that we were able to get to. We do have a lot of additional questions that came in and we weren't able to get to. And thank you also to each one of you for taking the time to attend and participate today.
And if people have questions they want answered, they can actually send me mail. And I'll try to answer as much as I can.
Okay, we do have a method of answering the questions that came in, and we can push it out when we send out the survey. So we'll go through that after we finish, and then you can send it. We'll send out a link to the answers after with the webinar with the link to the webinar that everyone will have to be able to listen to it again, to the recording. So it is recorded. It'll be available in a few days, and at that point we can also put the questions. You can find announcements on upcoming webinars and other activities at learning.acm.org and acm.org. Also, we have a quick survey, if you wouldn't mind filling it out, where you can suggest future topics or speakers and just what other things you could see on your screen. So on behalf of the ACM, SIG-AI, Kristian, myself, and Plum and Petros, thanks again for joining us today, and I hope you'll enjoy us again in our next webinar, which is going to be March 15th, which will be given by Dr. Tomek Strakowski, Director of the Institute for Informatics, Logistics, and Security Studies, and Professor at SUNY Albany on the topic of advances in behavioral computing. Please also take a few minutes to look at the SIG-AI web pages and join our group. This concludes the webinar. Thank you again, everyone.
Thank you, everyone.
Thank you.